Yeah, I would say cloud.
Sure.
Let's wait for 3 minutes more. I think I can squeeze my introductory words into 5 minutes, even though I'm allocated 10.
Or we can just until 15 past. So I guess we're not in a hurry or anything.
No, not really. But now there's 8 participants.
Looks like there's no need for the approval. Probably there's no need for this approval.
No, something like that.
Can we get 10? And we have 9?
We can wait for a while. So.
Oh, yes, sir.
Let's start at like 5 minutes past.
Yep. Do we get a verify instruction in your words, or can we get it now?
A very short one.
All right.
It's going to be included there.
Okay.
Yes, I guess. Verify the ground that all the current organizers are from Verify.
Yeah.
But it's not exactly a Verify event.
Yeah. And you're just hosting it.
Yeah. This time.
Yeah.
Oh, somehow switched back. So yeah, 9 participants right now. 1 minute to go. You want to be my operator here?
Yeah,
I guess so. Cool. All right. And then we have Colin Arndt joining. So now there's 10 people. And we have waited for 5 minutes. So let's start. So hello, all, and welcome to the first meetup for the HashiCorp user group of Helsinki. And I'm your host, Lauri Suomalainen, and we also have here in our meeting room Anup.
Hello.
And Antti.
Hello.
So without further ado, let's get to it. You can skip to this next slide. So Anup and I founded this user group because, of course, we are big fans of the HashiCorp toolset, and we're using it a lot in our work. And there's also Jacob, but the current attendant here in person. And it may seem that it's like a Verify event, we are all from Verify, but like these ideas just happen kind of spontaneously in a working environment. So one day we decided that, like, look it up and saw that there is no HashiCorp user group in Helsinki. So we decided to found one, and here we are. Enough of us. Let's go to the next slide. And today we're going to have 3 talks, starting with Antti, talking about the experiences using the Vault for application identity at UpCloud. Then we have our own Jacob Lafos talking about using HCL in a new project called Bubbly. And then for people who didn't attend the HashiConf Europe a couple of weeks back, or just want to refresh their memories, Anup has prepared a recap of the event for us, going through the most notable announcements and news. And then you have to bear with me for another 10 minutes after these talks for a little bit of a closing words. And after that, we're going to have a free phone talk and a socializing thing. I don't know how well that works in Zoom, but like how we're going to try. And feel free to post questions and comments to the chat there, and there's an option to raise hand, I guess. So depending on the speaker, we can have questions and comments later, or while they're presenting. And let's see, like this is the first time like doing a meetup, so some things are just taking shape. So if you want to give feedback to me or Anup later, you can send us an email, provide them like in the slide, latter slide, and also in the end. And all the slides and the recording will be shared later. So in case you miss something, you can always come back to it. So without further ado, like I would have 2 minutes to go. That's good. So we can just let Antti take over and start his own presentation.
All right.
Thank you all for being here. It means a lot to us. Antti, if you please.
Yep, sure. I have a microphone here somewhere, hopefully. Yeah, I think. Yep, I think we can leave it here. So yeah. Yeah, so microphone is not that far, but if you have any trouble in hearing or anything else, please let me know so we can adjust. Also, I kind of have a tendency to speak a bit fast, so if there's some parts that seem confusing, please say so and we can take it back. Can I have the keyboard, please? I think I can sort of take over. So my name is Antti Myyrä. I'm from UpCloud. I'm here to represent something that we're doing internally with like service identities and service authentication using HashiCorp Vault. So I'm gonna get to it in a minute, but first, since we're kind of presenting, I need to tell something about UpCloud as well. So let's see. Oh, I guess that's focused. Yep. All right. So what UpCloud is we're a European cloud hosting company, and we pride ourselves really with the performance of our services. So what we do offer is, of course, like servers, object storage, databases, that kind of stuff, and we do it globally from 12 different data centers around the world. And oh yeah, interesting. So our newest one is in Sydney, Australia, but we have had quite a few for some time now. For example, our Singapore data center, I think it's turning 5 years this year. So there's quite a few, and there's of course more to come on that front. And why we're here, of course, we're a HashiCorp technology partner. We do support Terraform, Packer, and so on out of the box. So you can use our platform with any of those tools without installing any special plugins. You can just specify UpCloud in your configuration and should get you started right away. But I'm also here because we are using HashiCorp products extensively inside UpCloud. So we have quite a few things internally that we are utilizing with Vault is the thing I'm talking today, but we have quite a few more of the stuff we're using. So something about me. I'm a senior software developer working for UpCloud's hardcore team. So we're a team that works with the kind of the most basics of our systems, like going way down to whichever the well is the deepest in our sea. And I'm a Master of Science. I've been a sysadmin previously and also a consultant. So been doing quite a lot with quite many different clouds and both public and private ones. And currently I've been for UpCloud for 2.5 years. I started working as a backend developer with some APIs and that kind of stuff. Then I moved on to working with our operations team, building some tools and some APIs for them to actually utilize our platform when they're operating in it. And currently I'm working with our hardcore team and working again with backend and APIs and some SDKs that are in front of our API. So you can use us with Python and Golang, and I think even PHP is on the menu. Not that I've used that much, but it's there for sure. So what we're speaking today, as I mentioned, that we have our farthest DC is in Sydney, and usually the time to get there takes a bit less than a second when you're actually calling there. So you can't really do that many round trips back and forth when speaking to whichever systems we have running there. So there's a lot of latency, and with that comes other things. Of course, we want to avoid the single points of failure in there as well. So for example, if the connection backwards doesn't work, we don't want the services to just raise their hands up and be like, we're not going to do anything because there's no connection. We want them to be able to perform. So there's that, and there's also the idea of who is it actually that is calling. So we don't want to pass the same credentials over, because that way, if any of our external services would get hacked, the attacker would have access to all other services in that area as well. So we don't want them to have a username and password there. And of course, when we are calling, we want them to make sure that it's us who's calling and some other person. Of course, vice versa, we want to be sure that we are calling the right person. So how do we do this? It's the issue of validation, and we use, as you probably guessed by now, we use certificate authentication to do this. So what we have is that we have a calling service that has its own certificate, and it gets passed in the request, and also the answering service will have its own certificate, and both can verify that it's the other one who's calling. And think of it what you will, kangaroos are from Australia, so they probably eat people as well. So that's that. So I'm not gonna dwell too deeply in TLS, like mutual TLS and certificate authentication, but basically it's so that both of the services have their own certificate that is validated by some other party, some external party or some other certificate authority that guarantees that this is the one that actually it's claiming to be. So it gets usually done like this for us. So why certificates? The main reason is that certificates have the attributes that are really necessary for us. For example, they have a validity. Of course, they have a time when they're issued on, when it expired on, and who actually has issued it. And there's also things like common name and organization and that kind of stuff that we actually can use for authorization, because of course we have quite a lot of certificates and not everyone gets to do everything. So it's not just, is your certificate signed? All right, go right ahead. So of course we want to be sure that they're the service that actually has the rights to connect to these places. And so doing your own certificate authority is quite easy. All you need is OpenSSL, as the saying goes. So of course you can use OpenSSL to create some certificate keys and create some certificate requests, CSR, and you can also sign it and use it wherever you want. But that's not really way to go when you're automating things. So you don't have any certificate revocation lists. You can't roll new keys. You can't automatically update anything, and of course you don't have any auditing either. You don't have a log that says that who gets signed what and where does it end up in. And of course, since we're a HashiCorp user group event, the hero in this story is Vault. So we're using Vault quite extensively, and I think most people know Vault by their secret engine. So you can store passwords there, you can create database credentials there, that kind of stuff. But Vault also works as a PKI PKI secrets engine, so you can actually create certificates from it, and you can add policies to them, and you can use them however you want. And of course, well, as you can see here, Vault works with quite many other things as well. They have a console integration. They have integrations with quite many public clouds. Not with us yet, unfortunately, but maybe later. But you can use Vault for pretty much anything. So it's the Swiss Army knife of anything secret. So it's kind of a better do it yourself certificate authority. And Vault also has of course the web UI that you can use besides the APIs and the command line client. So it comes with everything included that we need. You can easily do certificate renewal. You can easily revoke any certificates that you want to get rid of. You can have multiple CAs there, and everything gets logged. So auditing is also quite easy. So previously I showed you what it takes to use OpenSSL for these certificate things, but this is the sort of Vault command line version of it. So basically, you just create a certificate authority there. You add some TTL for it, time to live. Then you write some configurations. You write some policies, and then off you go to create your certificate for design. In this example, we have a drone 597 that needs a certificate for the identity service that is running under company.dev. And here we have just normal common names. Of course, there are other ways to do this. You don't necessarily need to use Vault. I think every one of us is kind of familiar with Let's Encrypt. Of course, it's free, it's in the internet. You don't need to host your own CA to do it. So with it, you get everything out of the box. But of course, with it, you get the normal limitations of like global certificate system. So you have a certificate transparency. Anyone else can look at what you've created in the certificate transparency logs. And then there's also the issue of network connectivity. So we're providing certificates for services that have never seen the light of day in the internet or anywhere else. And of course, when they're getting certificates, they should have either a network connection with HTTP, or they need access to DNS, so they can they can somehow prove that they're the ones who are expected to be. And of course, auditing with this is quite hard as well. So you get to see that, yeah, someone did create this certificate and has probably used it, but you can't see anything else like where did the request come from, who did it, what happened afterwards. So kind of auditing is really off the table with this one. And of course, well, in any bigger company, it's usually not all the people who have access to create these kinds of things. So with us, it's services and some really well selected people who actually even have access to these things. But not like everyone with DNS access should be allowed to create any certificates. So but of course, if it works well for you, you should of course use what you have. So I'm not suggesting that you all skip your current processes and go fully with Vault if it doesn't fit your use case. It's all about what's good for you and how you want to use it. So with that out of the way, we have some tools that we've created for working with Vault. We do have our internal Vault worker, which actually works quite similarly to Console Connect sidecars that you have in Kubernetes clusters and other places. So it has two modes of operations. It has a certificate mode, so we can use it for within a container or within a server to keep any certificates in there up to date. And the only thing that the application needs to do at that point is just reload the certificates from the file system whenever, in 5 minutes or in 2 hours or however. So that's that. And then there's also a proxy mode where it works as an ingress and egress gateway for any of our applications. So basically it takes care of the certificates, and then it will do all the TLS magic for all our applications. Or any application that we have doesn't need to care a bit about their authentication and their TLS requirements. They just need to connect their local host to some specific port, and then they can get going. And same with connecting that service. So they will just listen in locally and they will get connections that are actually validated, and then they can just go ahead. And it is written in Golang. It comes in a single binary, and it probably will be open sourced later this year. We actually had plans to open source it for this meetup already, but some things came up and we haven't been able to do it yet. But we'll probably publish it. Yes, I can promise that we will publish it before the next user group meetup that we have. So maybe we can do some Golang showcasing at that time then, if anyone's interested. So that's that. So as I mentioned, it's quite similar to Console Connect sidecar, but we began this project before Console Connect took off that well. So that's why we have our own, and also we haven't really been using Console Connect because of its debuggability. Because if something breaks, we really can't see what. So that is the reason that we have created our own. But of course, whatever works for you, you should use it. So if Console Connect does all the things you need for it to do, you should just go with that. And then a bit of a bird's eye view for the thing that we have. So our internal systems. So most applications come with this ingress vault worker and egress vault worker that offers their connectivity. And then we have some older services that, well, they have a vault worker for the certificates, but there's some different configs for that, and also a certificate authentication gateway to do some other stuff, which I will get to in a minute. So all of these will connect to a vault service that we have running in some of our DCs. It's good distributed as it should, and they will kind of keep their certificates up to date. But when let's say this application X wants to connect this service Y that we have there, first it connects to the certificate authentication gateway, where we actually strip the TLS for the first time, and we will add the common name to a header and encrypt it with our certificate authentication gateway certificate, and then connect the actual service, which will only talk to the certificate authentication gateway. We do this because kind of we believe that you should really kind of get rid of your TLS connections as early as possible, because the code can be quite hard, and it's not a thing that normal applications should be concerned about, because there's quite many booby traps that you can run into. So we have that, and then we also have our message queue. We use Kafka internally, but pretty much anything else could do as well. So that works with our certificate authentication as well. So if you want to talk to or publish to a specific message queue, you will authenticate with your certificate to it and then publish. And the same thing with subscribing to that message queue. That's also reserved for special applications that have access to that specific message queue, and then they can listen in. So whenever a message gets published, if there's anyone listening, they will get that and can operate on that one. And both of them work a bit differently. For example, our certificate authentication gateway adds the common name to a header, along with some other parameters that are gotten from the initial connection and from the certificate itself. And in the case of message queue, it will either add or override kind of those message properties that are related to those certificates. So no one can call it and validate itself and tell them that there's someone else. So we'll kind of use it for gatekeeping at that point in time. So there's that. And then some things that we have run into that probably learned the lessons either the hard way or some easier way. So I think the first thing is when you are getting to this, if you want to go down this certificate authentication path, is probably not make two short-lived certificates right away. Yeah, currently we have some hours for validity, but when we started with some days, because usually it's never production critical until it is, and for us it was something like 3 a.m. on Sunday morning. So probably something you want to avoid. And what happened was that the initial certificate renewal failed, and the application didn't really know what to do at that time. Then it lets its certificate kind of get old, and things got a bit hairy. And thankfully not a production failure for us, but it's still woke up some people in the middle of the night. So probably something you want to avoid unless it's really production critical at that point in time. But of course, the other thing that came to us pretty quickly is that you should keep your time in sync. And even if you think it is in sync, it's probably not. So you better check it. So with certificates and with like really short-lived certificates, time is quite important, because if you get a certificate that's actually based in like 5 minutes in the future, to begin, it's probably not gonna go well for you either. So you should do this, and I will later on tell a bit about tools that we're using to keep the time in sync for now. And then of course for the like public side, since you are using your certificates internally, it might be tempting to kind of go for it with your services as well and give those certificates to your users as well, so they can call in with their certificate and you can validate it similarly as you validate your internal connections. But probably that's not a pretty good way to go. Of course, you can use certificates or JSON Web Tokens, that's the JWT, as user tokens, but you're gonna run into problem with revoking them at the least. So that's gonna be quite a bit of problem. So if you have distributed services, just a word of advice, probably use OAuth 2.0 or OpenID Connect, that are really the standards that are built for it. So this didn't happen to us, but I know another company that kind of stumbled with it, and they didn't have a good time either. So some other things that to consider is that, as I mentioned before, you should terminate your TLS connections as early as you can. So especially if you're transferring things between insecure networks and are operating on sort of zero trust environments. So that's quite good there, but maybe in some secure places as well, because TLS can be quite hairy in certificates. And of course, anyone can craft any kind of certificate that they want. And the code processing, it can be good or it can be something that has worked previously, but there can be some problems as well. And with this, you're also accepting that if you're using certificate authentication, you are basically treating your common name as some sort of identity. And you should be careful how you treat your common names as well in your code. So for example, if you're using only 16 integers or 16 characters internally, and then someone comes to you with like 1 to 200 character string, might not go well in your code either. And of course, if you trust the headers explicitly, make sure that there's really no shortcuts to your application. For example, I showed you earlier that we have this certificate authentication gateway between our applications, and really the applications behind that don't speak to anyone else but that, just to be sure, even though they have a separate web server there as well. But if you do this, especially use either some authentication gateway or a web server, but don't skip both. Use either one. So you don't really use TLS in your code. That's really something that's not supposed to happen. And then of course some internal certificate authority stuff as well. So if you are like us using the PKI secret engine as your internal CA, you should have some safeguards in place. So either if you're working as a certificate authority, treat it like other certificate authorities are working on. So have your root CA key stored somewhere else, and maybe just create an intermediary signing certificate to your vault. So for example, the root CA can be something like 10 years in validity, but intermediary can be something like, usually a year or two, or even less if you have good processes to do that. If it's automated, it can be only 1 month. If the certificates it creates only last for a few hours, there's not a problem there. Or with, of course, if you're using Vault Enterprise, you can use physical keys to store your CA, which works quite well as well. So that kind of prevents Vault from having any access to it. And even Vault, if Vault is really secure and it is audited like yearly or so, it's still ours, and of course also HashiCorp's recommendation to not store production critical CA keys there. But of course, it all depends on what you do. If you're using this in your dev environment, I don't think there's that much harm in any of it. So use Vault or you want. But if you're protecting your customer data, then it might be good to do something else as well. And then some tooling that we're using. So we aren't personally using console template, but it actually does the same thing that our own Vault worker does. So it you can set it up and it can keep your certificates in sync. I'm not actually sure why we weren't using it. Probably it either didn't exist by the time when we created our own Vault worker, or then we just didn't know about it. It's probably one of those two things. But what we do use in some of our services is this Vault token helper secret tool. That is there's this project called libsecret that is a secret tool for using our secret slide certificates or anything else. And then there's this Vault token helper that one of our guys has actually written for it. So it's highly recommended, and you can use that to safeguard your secrets while you wait for the open sourcing of our great Vault worker, or maybe after that as well. It's quite good and works quite well. And as I mentioned before, you should use some web server to stand in front of your application and actually do the TLS termination for it. So HA proxy and Nginx have been serving us quite well. You can use Apache if that floats your boat, but I really wouldn't. But that's just a personal opinion against it. So if you do and it works for you, then go for it by all means. And maybe use Cronity instead of NTP, because this is something like the hard way. But NTP really, when it's enough out of sync, it's just decided, oh well, maybe the clock is right and I'm wrong, and it kind of stops syncing it. So you're probably not going to want that. So Cronity is just a better software and works much better in keeping the time in sync. So even though it takes a bit of configuration, I would really suggest using that to actually make sure your time is correct.
Is there a blunder behind you're starting with NTP and then switching to Cronity?
Oh yes, there is. I'm sure. Well, let's say in one of our services has had an incident in this past year that was related to someone using NTP instead of Cronity, even though we do have a company recommendation not using NTP. But well, things happen and it got resolved quite fast. But yeah, and NTP is not good for you or name others. But if you want to go down the same path, like using certificate authentication, there are some reading I suggest. So of course, Vault has its own PKI secret engine documentation that is really good. You should learn that. And also HashiCorp's learning platform actually has a built your own CA tutorial that you can read through. So those are quite good initiation to how Vault does things. But then there's the more general stuff with certificate authentication failure stories that are out there. So there's a quite good blog post that are linked here. I will post these slides later on so you can get to it. But then there's things like CloudSec lists, any incident reports, probably Hacker News, and well, Stack Overflow maybe as well, because there's been quite many stories of people like, oh yeah, we didn't get the verification to work, so we just disabled it, and look what happened. So if you're using this, please use it properly. So not any half-hearted attempts. So I guess my time is kind of done, and I will be glad to answer any questions or comments that you might have on this. So if you're using our own or think that our approach is wrong or anything else, please voice your concerns.
I had a question about using console, but I think you have handled that already. So like when you talked about the worker.
Yeah, our worker kind of does the same thing. We are considering console like continuously, and we have some proof concepts on our platform that actually are using console and console connect. But so far we haven't been able to debug some failure scenarios as well as we'd like to. For example, there have been cases just some service stops accepting connections, and it's really hard to find out why. The connection just gets resetted, and we can see that we can see that console is listening in on it, but there's nothing in logs or anything else. So we're still kind of on our toes with it. But of course, if those things would get resolved, we would probably move to console completely, because it's always better with like crypto and TLS and everything else. It's good when the people who really know their stuff are doing it. So that's that.
Do we have any questions in the
chat? In the chat, are there any questions? Feel free to ask.
Or you can, I don't think anyone's muted, so if you're interested, you can just voice out as well. But if not, because I will skip to my last slide before we finish this. So thank you all, and just a short commercial. So if you're interested in this kind of stuff and are working as a developer or systems administrator or anything in between, we do have some quite nice openings coming up in the fall related to these things. So if interested, please visit shops.upcloud.com or message me after this. It's anna@upcloud.com. So whichever you prefer. But thank you for listening, and thank you for allowing me to speak here with this.
Glad to have you with us.
I guess we can move on to the next one. How long do we take? Something like 30 minutes. I guess we're a bit ahead of schedule, but
ahead of schedule. So let's have a 5-minute break, and let's prepare the floor for Jacob. Jacob is joining us remotely, and I have to make him at least a host in the Zoom so he can present his own slides.
Can you hear me at least?
Yeah.
Okay, cool. Audio works.
Cool.
Yeah, I can stay here now so that when people take their 5-minute break, we can at least be prepared with the necessary rights and things. Oh, I'm host now. Okay. That was quick.
Yeah.
So
you can resume back.
So can you see my screen now?
Yes.
Yeah, we can.
Cool. Okay.
So we'll be back in 5 minutes, and go get refreshments, maybe stretch a little. That's what I'm gonna do. So 5 minutes. Let's go back.
Okay.
All right, hello, welcome back. 5 minutes have passed, and let's have Jacob present his own stuff about using HCL in Bubbly, a new project from Valve Code. So, Jacob, can you show? Do you have a camera there? So we can see your face.
Yeah, maybe. I'm not sure if you want to see my face.
Mandatory.
How do I do this? Okay, there we are.
There's a
Hey.
man behind the words.
Hello.
Yeah, exactly. I have my window open here, like it's so hot.
Yeah, I'm going to mute myself now. So go ahead, please, and thank you.
Well, thanks. And you can see my screen. Should be VS Code at the moment, but I do have a presentation, so that's perfect. Yeah, so well, I've given quite a few presentations, and whenever you apologize before you start presenting, somebody afterwards always tells you that you shouldn't do that. But I'm going to do it anyway, because yeah, my first daughter was born under 2 weeks ago, so I'm actually on paternity leave right now. So I've had maybe less time than I would like to have prepared for this, because I didn't do anything until like a few days ago for this presentation. So sorry about that, but I tried to summarize everything that I could think of and pull it into this for you all. So yeah, so briefly about me, continuous practitioner. So I started working with CI related things in the early 2010s. So lots of Jenkins back then. But then now last 2 to 3, 4 years have been more and more infra cloud, I guess general DevOps things. So yeah, I'm one of the founders of Verifa, and we started this sister company, or like daughter company, whatever, called Validcode, because we have been developing this tool called Bubbly, and we wanted to keep the two a little bit separate. So Bubbly is what I'm talking about today. And yeah, in my free time, play piano. I'm a juggler and now a father as well. So that means I'm sleep deprived and all the other good things that come with the package. Yeah, and a quick disclaimer as well. I'm not an HCL expert, so some of the things in here might be wrong, or maybe not wrong, but you know, like not like the best thing or the most amazing advice ever. And if so, I'm sorry, but I guess this is one of the points in this talk as well, is that working with HCL is maybe not as easy as it could be. And yeah, hopefully I cover some of those points. But yeah, short agenda for my talk. I'll give a quick intro to Bubbly, and then I'll talk about why, well, first of all, what HCL is, and then why we decided to use HCL for Bubbly, and then some examples of using HCL, and this examples of parsing and using HCL is where I wanted to spend more time with more practical examples, but I have at least one semi-good example that I can run through today. And then, yeah, some of the gains and challenges. So what do you get by using HCL over just using JSON or YAML or something like this? And then what are some of the challenges as well with using it? And I guess this is intended for anybody who's using HashiCorp tools and HCL, I guess primarily Terraform, because the other tools don't really use HCL in such a powerful way. They are more using it as a config language than anything else. But anyway, it should be interesting if you're interested in HCL. And especially if you're looking at building some tools, could be internal tools, could be, you know, whatever, and you're interested in a DSL or, you know, some kind of high-level scripting language, or even just a config language, and don't want to use JSON or YAML, then this could be useful for you and help you consider if you could use HCL. So briefly about Bubbly, it's an open source tool that we're building, and the main focus is on release readiness, which is about trying to capture all the data, or relevant data that we care about in CI/CD practices, so that we could make nicer decisions, make smarter decisions, not like, okay, we have this tool that does this and this tool that does this and this tool that does this, and then Our CI process produces data about test automation, about code quality things, about OSS licenses, about CVEs, and it gets like pushed to all of these different places. And then you want to make good reasons about that data and use it to help drive your continuous delivery practices. So we're not aiming to replace any of those tools, and we're not aiming to do any kind of analysis or anything like that. All we want to do is build a nice way to collect this data and then use it for, to help you basically. So yeah, problem statement is that if you are working with CI, and I would say more advanced CI, if you're like a small team, couple of developers, and your release process is basically, we have a CI pipeline, we run our tests and we run some static analysis or some linting, and if that all passes, great, then we go to the next stage where maybe there's some integration tests and so on. I mean, if this is your release process, then probably you don't need something like this, but once you start building more complex software, bigger teams, bigger everything, and more tools get involved in the process, then this is where the value for this would increase, I would say. And a couple of interesting things that we're trying to tackle as well is the dependency across repositories. So CI is focused on a specific repository, but then nowadays it's really common that you have like CI pipeline per repository, and then actually a release for a project or for a product is a combination of repositories, so different commits from those, and getting visibility across those as well can be quite challenging. So yeah, the main thing behind this is basically a model of a release. So this is essentially what we want to capture with Bubbly, and I think this is a good intro as well to the HCL side of things, because here we have a release which is based on a Git commit, and then we can log activities against that Git commit, and we can define stages that have criteria. So like, okay, security, and within security, we want to make sure we've ran these tools or we have results from these different tools. And then we would log something against each of those criteria to say that, like, yeah, this has been done or not, and what the results from that were as well, and then start to track things like artifacts as well that are being produced and calculating SHA sums for those, so that we could link releases together based on artifacts. And then in the bottom right here are the results from the different tools. So this is really where HCL comes in, and we wanted a way to be able to take results from lots of different tools and lots of different outputs. It could be calling a REST API, it could be parsing a JSON file, it could be, well, that covers like 80 to 90% of use cases from my experience, but yeah, you get my point. It could be GraphQL, could be some YAML file, they could be scraping from some random location, some CSV file, or some like random formatted text file. Basically being able to grab information from anywhere and then convert it into our schema, and then put that into this release model, so that we could use that data to drive our release readiness definition. Cool. Yeah, and then about the releases. So if you consider that model one Git commit that we would create for a release candidate, then the idea is that we could link these releases together, and this might symbolize more what we do now with modern software development, that we don't just have one repository with like everything in it. Usually it's one repository for the code, and we might even have another repository with our YAML definitions for deploying to Kubernetes, something like this. So it doesn't even have to be like all code or all project code. It could be other things as well. All right, so and please feel free to like ask questions at any point. I'm quite happy to just stop and start. There's so few people in the meeting as well that it's fine. And I guess if Lauri or somebody could check the comments, then if you don't want to shout out, then that's good. But yeah, onto HCL. So HCL is the HashiCorp config language. I'm assuming everybody here has worked with some HashiCorp tooling, so they have come across HCL. I know that the older versions of Vagrant and Packer were using maybe Json, but nowadays they are being ported to HCL as well. I guess the main fame for HCL is because of Terraform, because, well, like I said earlier, most of the other tools are fairly simple when it gets to HCL, but Terraform have really like pushed the boundaries with what HCL can do. Anyway, it's open source and written in Go, so that's the repository. It's pretty powerful. I can maybe show some of its power a little bit today. One thing that I always come back to is it's called a config language, but it could also be a scripting language. And I think this is kind of an interesting question, and hopefully I can give you my view on this today, whether it's a config or a scripting language. On a high level, for me, it's about how you use it. In Bubbly's case, we're using it in both contexts. We use it just as a basic config language, but we also use it more as a scripting language to do, to do more like dynamic and interesting things. And yeah, just a note on versioning as well, that they're HCL, the default version now is version 2. So if you go to the Git repository, the main branch or the master branch is now version 2 of HCL. That's changed in the last 6 months or so. So I think HCL v1 is not being used that much anywhere. I think there's maybe a couple of HashiCorp tools are still being ported over, but yeah, HCL v2 is the only thing I will talk about today. So yeah, really quick intro to HCL as a language. These are the main things you need to know about to write some HCL and to even start maybe figuring out what you could do with HCL. There's basically blocks, which are these stanzas as they're called in other places. So you define like a name, and then you have some curly braces, and you can have a block name and then a label as well. And this has to be a string. You can't do anything else here than a string. So you can't do variables and stuff here. And yeah, if you worked with Terraform, then you would know that this is how you define resources and data blocks, as you say like resource, and then the type of the resource, and then an identifier for the resource in your scope. There's attributes. So these are, well, like variables in a way. Something equals something. And the expression could be quite a variety of things. So, so we have expressions. They could be like for loops, if statements. They could be constants. They can be function calls that then resolve to some value or something like this. But underneath the hood, every single expression should resolve into a value, and I'll get into the type system that HCL uses under the hood as well, because that's pretty important if you're going to be working with it, at least building like a scripting language with it. But yeah, also the Terraform documentation is much better than the actual HCL documentation for most things. So like if you have questions about HCL, one good thing to do is always to check the Terraform documentation. And yeah, then lastly, a body is the thing that ties all of this together. So a body is a collection of attributes and blocks. And then within a block, you get another body. So that's how we can build some sort of abstract syntax tree or some tree structure of HCL, is that you always start with a body, and then within a block, you'd have another body. And then you can like recurse down as much as you want. And there's this thing called the eval context, so evaluation context. And this is where functions and variables and things are stored. So when this piece of HCL gets decoded, the eval context is quite a good thing. Well, you need to know about it, because that's where it's like the symbol table for a compiler or something like this. This is where the decoder is going to go and look for variables that are being declared or functions when they are called. Okay, yeah, so if this is how basic HCL is, then one question now might be that what about all the Terraform stuff? Like, what about modules? What about the variable blocks you can create, the inputs, and these sorts of things? So this will be one of the main challenges that we came across, and one of the main pains as well is that everything Terraform does besides this stuff is all Terraform stuff. It's not HCL stuff. It's like you can decode HCL into some Go struct and you can do it yourself. But if you want to start implementing modules or variables or inputs or local variables, this sort of stuff, that's all handled by Terraform. And not by HCL as a language, which was well, maybe not so much of a surprise, but when we started working with HCL, I was kind of hoping there would be a nicer way to do this, or maybe some nice tutorials that how to write something somewhat similar to Terraform, but there really isn't, and that cost us quite a bit of time because yeah, I'll get into the lesson learned later. But yeah, why did we choose to use HCL for Bubbly? Well, I guess an opinionated answer would be that we like Terraform. We like to write Terraform configs. This has two sides to it as well, because once you start getting fairly complicated with Terraform, then you start to think that maybe having a coding language would be easier. But at least for the intermediate and simple cases, declaring Terraform stuff is super easy. And HCL has a lot of built-in goodies like these expressions that I showed you earlier. And I think this lends itself to a very good use case that if you want to have your users be able to convert data, do some validation, do some checking, do something with the raw input, then HCL has a big advantage there because of the functions and these sorts of things you can add and create, and where you can use the Terraform standard library too. I think there's a nice level of abstraction with HCL as well. It's maybe this is another opinion, but to me, it's not too much code and it's not too little code. I think it's a fairly nice level. And we definitely didn't want to invent our own DSL. So the major competitors, let's say, or alternatives, were to use JSON, which is like a compiler for JSON. So you can do some dynamic stuff and it will just compile to JSON, and then we could input that with all the nice JSON goodies that exist in the world. Or then to write our own SDK and then expose that with, I don't know, Python, Golang, or TypeScript or something, so that you could basically code the inputs. So if we take a look at an example of what we can do now with Bubbly, and this is actually, we're going through some fairly significant changes internally to the data structures and to the data abstraction layer, or data access layer, sorry. So this is going to be like, this is the new syntax, and will be available in, I don't know, a couple of weeks, maybe. It's not that different, but anyway. So we work with a resource system. We wanted a way to basically define like building blocks for converting data and bringing it into the Bubbly schema. So we created this resource system, which was obviously inspired by something like Kubernetes, where we would define the kind of resource and then a name for it as well. So in this case, I'm inputting output from Go test into Bubbly, and this is the transform. So this is the interesting part where we take a raw input from Go test in this case and convert it into our schema. So we define these stanza blocks here, which then create some like data block when this is passed, and those data blocks will then be the ones that end up in the database. So we can say that we have a test run using the tool Go test, and it's type unit test. This gets automatically joined to a release when you run this. So I showed earlier the model of the release and how we want to associate all the data together. That happens automatically in the background. Then we can say that for the test run, we had some tests, and then we can use this HCL extension, which we can create these dynamic blocks. So this is available in Terraform as well. But what we do is we say create a test case for each of these values. And this is not such a nice example, but maybe also an interesting example, because the Go test output, anybody who works with Go and runs Go test and has ever tried to parse the output of Go test, it's really like, it's really not that well structured. I think most people don't parse Go test output. So we have to do some filtering here. We just check that every single record that we care about has this test property and has a package and has an elapsed, because those, if there's a test, if there's a package and an elapsed time, then it's a test case result. So then we care about it. So for each of those, then we define our test case, which this is a really simple version now. We basically give it a name and we define a Boolean here to assign to the results. So, well, this is now showing some of the things you can do with HCL out of the box, that this lower method exists and it converts a string to lowercase. And then here we're resolving some variables and accessing the action property and then doing an equals to return a Boolean property. So this is what we have, like the main use case for HCL in Bubbly, so that we can do these kinds of things. And doing this with JSON or something else would be possible. We did do some prototyping in the early days with it, but we just found that HCL has a really nice use case for this kind of like declarative way of saying, here's some data, I want to do some dynamic stuff on it, and then like assign these fields to this data in the schema. Briefly about the main packages in HCL. So this is now moving into more of the using HCL. The main package I would say that most people should care about is this Go HCL package. So if you go check the repo, this is just a directory there. And this gives you a way of defining Go structs with struct tags. So the same way you would decode JSON, you can encode and decode HCL. And this will then just give you like here's my HCL, here's my Go struct, parse the HCL and decode it into this Go struct. And if that's what you need, then Go HCL is your friend. It's really simple. There's this HCL Deck as well, which is a bit more involved. And the main reason for having this is that if you want to work in the CTY type system, which is the type system behind HCL, you can do that natively. So you don't need to go into Go struct and then back into CTY, or do this kind of like jumping between the two. You can just say that like, here's a structure of the HCL, create a CTY type from this. And then obviously the core HCL package has these things called schema body that allow you to define the schema of some HCL code as well. And these are kind of like going in ascending order of difficulty, and also in some flexibility that, like I said, the easy case, I have a Go struct, here's my HCL, you know, do your thing, use Go HCL. If you want to get a little bit more involved and work with CTY type system, there's HCL Deck. If you want to go hardcore and do all your own parsing and all your own everything, then the core HCL package with the schema body is your friend. And this is what Terraform uses under the hood. But Terraform creates its own abstraction on top of schema body called config schema. So config schema defines like how many blocks of this type are allowed. Is this attribute optional? Is this attribute required? These kind of things, so that Terraform validates your HCL when it parses it as well. It doesn't just like parse it and give you some attributes and blocks, which is what schema body would do. And then, yeah, there is an extension package as well in HCL. So things like the dynamic blocks, type expressions. So being able to take, like if you've defined an input in Terraform, you can specify the type that, hey, this value is a string, this value is an object, something like this. That's a type expression, and that's another extension in HCL. And there's a couple of other handy things in there. But at least those are the main two ones that we have been using. So if you feel like the basic HCL stuff is not enough, then this is where you need to look. And I guess a warning here as well is that these are extensions, so they're not built in to the core HCL. And that means you might have to do a little bit more work than you were anticipating. Like the dynamic block, you don't just give a flag and say, actually, here's my HCL now, like expand these dynamic blocks. Instead, you have to wrap the HCL body that you have originally into this new body, which then when that gets decoded will, expand the dynamic blocks. So you have to change your way of parsing the HCL and decoding it a little bit to do this. It's not just add a flag or add a simple thing. Okay, so to get to some practical things, I created a small repository here. So maybe I show you this a little bit so that it's not just presentations the whole time. Okay. So here is the example that I showed you earlier. Please say if the text is too small, I can make it a little bit bigger. So here's the HCL from the earlier example, and I'm going to show how this can be decoded with Go HCL in a very simple way. If you don't know Go, then I guess some apologies, but also this isn't very complicated. So so please bear with me. I have this Go HCL file where I define some structs. And as you can see here, we have these HCL tags. So what the Go HCL package is going to do is it's going to reflect this type, the struct, which is, well, reflect is the Go package. So it's a bit like looking at the actual struct underneath and checking like, what are the fields, what are the struct tags? And it's going to say, oh, okay, I'm expecting an attribute called tool. So to no surprise, that's this guy here. And well, it's an attribute. And when I decode it, I'm going to try and decode it into a string, and I'm going to assign it to the member tool in test run. So if this wasn't a string, or we couldn't decode this into a string, then it would error this kind of thing. So it's like it's deducing the structure of the HCL. It's creating the schema based on the structs and the tags. And yeah, that's the rest of the structs. So I've written some simple test cases here, and basically this is what you need to decode this. So we need to create a wrapper around the test run to say that like here's the parent, and within that we expect a block of test run which we should assign to test run. And then there's this HCL simple package, which I didn't mention earlier because it's not really worth mentioning, because all it does is wrap around Go HCL. So I could write 2 or 3 more lines of code here, and I would use Go HCL directly. But there's this HCL simple for simple cases, and this is a very simple case. So I could run this, and we would see that it should spew out the, oh, it spewed out my other one as well. Spews out the results. So here we have our struct, which is now created in memory, and we have our values that you saw earlier. So what I'm trying to show here is that if this is what you want, like you want to define HCL as a configuration, let's say that here's the values and things for running my tool, then it's really simple to bring that into a test run struct. I just heard a bell go off. Does that mean? Was that from Zoom, the bell, or? No, okay, I'll carry on.
It's not from Zoom.
Weird. Okay. Yeah, so let's look at a slightly more complex scenario here. That what if we wanted to define an input, a bit like you can do in Terraform, that we're going to have an input called tool, and here's a type. And then we actually want to define some inputs to like assign to this value. Obviously, you wouldn't have these next to each other. That's stupid, but you get like the the example here. So this would be in a module, and this would be in a thing where you call a module, for example. And now maybe we want to have some variables in here as well, that when I run this, I want the tool inputs to be assigned into the eval context, and then I could access it from within a test run. This is now, like I said earlier, the Terraform stuff is Terraform. The HCL stuff is basically blocks, attributes, expressions, and the eval context. And how you like connect this stuff together is up to you. And that means you got to write some code. The code is not very complicated. It's basically here. We've figured out some tricks here these are things we had to learn because we couldn't find anywhere online saying that here's how you do this. But basically what we do is we use the Go HCL package to decode this HCL, but we only get the inputs, and everything else gets assigned to this leftovers with this remain tag. So we basically say, put everything else here. This is the stuff we care about. And then now we could do some stuff with the inputs, like convert the types. This is now using an extension that I talked about earlier, like converting the type into an actual CTY type. And then we could loop over the input definitions and validate that the name exists and that the types are equal as well. So that basically what we have declared as an input and what we give as an input, so the declaration and the definition match. And then we assign these in this eval context. So this is has variables and it also has functions. And then we can decode the rest of the body, providing this eval context and again our struct wrapper that we created just for this test. So I guess the main thing I want to highlight here is that if you are looking at HCL and you want to start being like creating some cool scripting language, which is exactly what we were planning to do. We were like, yeah, we're going to do something like Terraform. And then like 2 weeks later, we were still like, how does this thing work and fit together? And it's because you got to do it all yourself. I'm not saying you shouldn't do it, but it's maybe a little bit of a caveat that there aren't any frameworks around HCL yet, at least none that I know of. Like there are no frameworks around HCL parsing yet that allow you to do these kind of basic things. Cool. Anyone interested in this and looking at it in more detail? The repository is available here. I think I made it publicly available. If not, please contact me. In fact, I'm just going to check that now because I know if somebody goes to check this later, they are not going to tell me probably. It looks public, so that's fine. So yeah, you can go have a look here and have a look at the code. Up to you. And yeah, like mentioned, this Go HCL package is what I would recommend for most people. If you really are planning to write some crazy scripting language, a bit like Terraform does, then you will hit limitations with Go HCL. But if you need something somewhere in between, which I would say Bubbly is, if we go back to these resources, like these resources on their own are not that complicated. So we use Go HCL for parsing these. Actually, this I say that, and the only resource kind that doesn't use Go HCL purely is this transform one, because this the stuff in here is very dynamic, and there we actually do code generation to generate the schema and parse it ourselves using the core HCL package. But in every other case, we're using Go HCL to parse all of the HCL in Bubbly. Okay, I have hopefully running out of time, so I'll keep the next 3 slides fairly quick. There's gains, the challenges, and lessons learned. So I guess the gains for us using HCL is that HCL is pretty powerful. And that's not because of us. We have basically copied all of the well, not copied, but we import the Terraform functions into our HCL parser. So basically anything you can do in Terraform right now in terms of functions and such, you can do in Bubbly, and it took us like 5 lines of code. One of those is an import statement. The other one is in the Go mod file. So like it's really nice that Terraform exists there, and I guess that's another point too, that there is this like standard library. I put it in quotes because it's not really a standard library, but I guess you could consider it somewhat of that. That you can just import into your HCL parser and make use of. And also there's lots of good documentation around Terraform, so that's been a major source of us learning about HCL is digging through the Terraform docs. And then, yeah, if you want to extend HCL with your own functions and variables, which we have, we've added a debug function, which basically you give it a value and it assigns the value as it normally would, but then it also prints out the contents of it to the console. Then you can do that. So we've added just some really simple things in there. And obviously the variables we use quite extensively with inputs and these sorts of things. So. But yeah, like I tried to show in my simple test example, it's really not as simple as, yeah, it's just, here's some HCL, I want to do this. You got to like code the logic, and you got to code your own scripting language around it. Some challenges that we have faced. I would say that the developer experience is not something that's just for us and Bubbly. It's also around Terraform and the other tools like Nomad and Console and so on. If you work with JSON and YAML, it doesn't really matter what editor you use, what operating system, or what, like anything. You get syntax checking, you can get schemas for it, you can get lots of other nice things that make writing it fairly nice. I feel like with HCL, a lot of this is lacking, and I don't know a way to add, for example, auto-completion to our HCL like writing. So even though I could tell you the schema, the entire schema, because we auto-generate it anyway, I don't know how, like there isn't a package to add auto-completion into HCL that I know of. So that's, yeah, I think that's a fairly significant point to consider, that if you're writing a tool that's going to be used by people to configure things, then configuring things should be as nice as possible. Another point, that converting to JSON, we wanted to write these HCL resources that you would like send to the server, and it would store them there. And then when you want to use or apply a resource, it would like pull it from the server and allow you to use it. So obviously we need to convert this into some format that we can send over HTTP or REST or something. So JSON is an obvious one. And if you look at the documentation, you see lots of HCL and JSON next to each other, and you think that they are like compatible. Technically, they are compatible from the parsing perspective, that you can write the same HCL as JSON, at least for the most part. The issue is that you can't convert between the two, that if you pass some code using HCL, you won't be able to generate the like JSON equivalent of that. And there's not just me being a little bit annoyed about that. I think the maintainers of HCL are a little bit annoyed by that, because people keep asking for it, and there's like a couple of GitHub issues where people go to great lengths to explain why this is not so easy. And after looking at the code and understanding more about HCL, I also understand why it's not so easy, but it's a little bit annoying. So what we do at the moment is we just pass the raw string, like literally the HCL that you write, we just pass that as a string in a JSON field, and that gets stored in the server. And then when we need it, we decode it again later. Anyway, the resources that we write are so small that we're talking about like fractions of seconds. So we don't really care about a performance factor here. So it's just not pretty. And from an engineering perspective, when things aren't pretty, engineers get upset, and I got upset about this. Documentation, yeah, it's pretty lacking. You can do the HCL simple and the Go HCL examples based on the documentation, but as soon as you get into these sorts of things that I showed you with like input variables and this other stuff, there isn't really a nice guide for it. I've included a couple of links that will help you at the end of this presentation, and a nice video that was made as well by HashiCorp. But yeah, I would say it's a hurdle in the beginning. Once you get familiar with HCL and know what you can and can't do, then it's not that bad. But in the beginning, this was a bit of a hurdle for us. And another maybe this isn't so much a challenge, but maybe a bit of a negative, is that the GitHub repository for HCL is not really that active. They are obviously making changes to it frequently to keep up with Terraform demands and other demands, but there's a lot of PRs and issues raised by the community that don't really get addressed that quickly, which is, yeah, I mean, it's always a bit annoying. I raised a PR maybe 2 weeks ago with a test case and with some other things, and still no like comment or no anything. So yeah, it's a little bit of a downer. But anyway, the thing is stable, and there's constantly things being added to it for Terraform. There's just the community side of it doesn't seem to be that strong, and maybe this is connected to the documentation as well. That if there was a stronger community around HCL, these two would be solved. Okay, so some lessons learned. I think the number one lesson we learned is don't copy Terraform. If you're going to write something that uses HCL and you want to make a nice scripting language, don't just start writing a parser and some DSL. It's a little bit what we did. Like I said, I think we were expecting there to be some nice packages or some nice wrappers around this, but there weren't. And then we just ended up starting to write our own like directed acyclic graph to handle the resolutions. I think our verse version had a symbol table in it. I have some compiler theory and written basic compiler. So I was like, all right, I'm going to create a symbol table and I'm going to pass the code and, you know, do all this nice stuff. And then, and actually what we've ended up with in the last version is like the simplest thing possible. It's basically what I showed you in our test case. It's that times like 10 or times 20. But often the simplest solutions are the nicest solutions, right? It just how you get there is difficult. So I would definitely say that if you're going to use HCL, define exactly what it is you need to do from the beginning, and then write the basic thing that you need to do to get there. Don't maybe consider every single edge case and write the most formidable parser known to man, because you're going to have to do all that yourself, and that takes time and energy. If you do it, please let me know. I'd love to see it. And yeah, this remain tag that I had in the test case, which is basically like, give me these structs, give me these fields, these attributes, these blocks, ignore the rest, is a lifesaver. It kind of tricks the Go HCL parser to not be too strict about like, oh, you didn't actually declare this field, and oh, you didn't declare this block. It's just like, oh, this wasn't declared. I'm just gonna like sweep this under the rug and leave it there. And then you can like extract things from the HCL that you care about, look at it and inspect it before you parse the whole thing with type checking, with schema checking, with all the goodies that you want to have at the end. So this is kind of like a way to trick the parser and get things out. I didn't talk much about CTY. I think it's actually pronounced like CTY. We've been calling it CTY for almost a year, so I'm going to keep calling it that. It's the type system that Terraform uses. So when you do things in, it's the type system that HCL uses. So when you define like variables and things like that, those are stored as CTY values. And the Go HCL package can decode directly to Go. It can also decode into CTY values. And that's what we do in every case is we decode into CTY value, and then everything that goes from CTY into pure Go, we handle ourselves in Bubbly, not in like the HCL package. And this has helped us a lot, just having this separation, because otherwise we were like, half of the struct is decoded into Go, the other part isn't. And then there's always this question that like, there's basically state in a struct, and I'm not a big fan of lots of state in a struct, where like call the init method on the struct and, you know, convert everything. So we just do everything in CTY value. And that means when you use this struct, or when you use these values, you can't just, you know, read it directly. You have to, you know, you have to convert it all to Go, at least the bits that you want. So I found that just nice, like architecture from a coding perspective to have that separation. And yeah, some useful resources. This YouTube video, it was our main starting place to get a feeling for what you can do. So I would recommend going there. If you're interested in what kind of like functions and things you can define in HCL, then there's the Terraform and CTY one. So CTY actually has a standard library of functions. So that's really like a good place to have a look, to see what's already available, what you need to do. And maybe looking at existing source code as well. We spent a lot of time looking at the Terraform code base, for better or worse. It's not the cleanest code. I mean, sorry, that came out completely wrong, but it's like, it's a big project. It's transformed over time. The parser has changed. It's quite like, from a newbie perspective with HCL and stuff, it's maybe not the best place to go. You get to see some really cool stuff, but yeah, if you're looking for simple use cases, then maybe not. And maybe Bubbly could be a point of reference now as well, if you're looking to do something similar. Otherwise, the other Hashi tools like Nomad and Console and Vault and so on, they use HCL as a config language, at least to my definition of a config language. It's like, there's no real like scripting or DSL or anything in there. Cool. But yeah, thanks for the opportunity to present about HCL. Realize it's a bit of like an edge topic around HashiCorp things, but if you're interested in the Hashi tools, then probably you were interested in HCL, and hopefully I was able to give you some like information on HCL that maybe you didn't have, or maybe you're just curious. But yeah, feel free to contact me if you have any questions, or if you want to like like find out more about HCL, or then if you're interested in Bubbly too, check out the GitHub repo, or get in touch. And yeah, we're also hiring for one position at the moment to help us. We're a small team of two people at the moment, so like really early stages at the moment, looking for somebody interested in this like CI/CD space and data and release readiness, with all the challenges of building a like application in Go as well. I guess we could open up for questions and things like that, if there are any.
Oh, thank you, Jacob. One question came to my mind. It's a little bit of a red herring, maybe, but you mentioned about the community around the HCL, and also like you kind of called out for proper parsers, maybe some developer tools and so on. So do you reckon that HCL would be like a proper challenger for more household names like Json, if given some time and love? Like configuration language space.
Well, I think if you're comparing HCL and Json, then I mean, Json you can parse in any language under the, well, any language that exists, at least popular one. HCL is only Go, as far as I'm aware. So like there's a major limitation, but if you're working with Go anyway, which most new like modern DevOps tooling is, then using HCL as a config language is absolutely fine. It's like stable and good. I think it's so like, yeah. I guess there's a difference between the parsing, which is like, here's my HCL, creates, an abstract syntax tree of it. That's like the job of the parser, at least for sake of argument now. Then there's the decoding, that taking that AST and turning it into something useful in your code. If we call that the decoding stage, it's the decoding of more complex things that doesn't exist today. Like, for example, if you had to rewrite Terraform, a module, and calling a module, these sorts of things, you'd have to code it all yourself. All you could do is parse the HCL and get your AST, and then you have to create the DAG, the directed acyclic graph, which is what Terraform does, to handle the ordering of, like, I need to resolve this, so I can resolve this, so I can do this. All of those things would need to be handled by your code.
Thanks.
Yeah,
Any
hopefully
other
that answers.
You can probably also unmute yourself and ask straight away instead of relying on the text chat. It's a tad bit quiet, but thank you, Jacob.
Thanks for having me.
Let's have another 5 minutes or until 1945. And how do you prefer, Anup?
We can have a 5 minute and then.
Okay, so 5-minute break. We'll be back in 1930, 41.
Yeah.
So thanks, Jacob, and soon we will have Anup on the mic. Thanks. All right, so we're back. 5 minutes passed quite fast, and we didn't get the coffee because the coffee machine was heating the water, so that happened. Anyways, next we'll have Anup, and he's prepared a recap on the HashiConf Europe, which was a couple of weeks back. I'm looking forward to this because I didn't have a chance to watch any talks there. So exciting stuff, probably, hopefully. I don't know much about it, but without further ado, let's have Anup on the mic. Thanks.
Hello. Yes. Thank you for giving me this opportunity. Thank you all for coming here. So this presentation is about HashiConf Europe 2020, which just happened. Is it 2 weeks? Yeah, 2 weeks from before. So in the sense, pretty lots of new things. In this presentation, I'm not going to cover the topics which were given by the core, not the core people from HashiCorp. So there has been also many other companies who actually came to the HashiConf and then presented their solutions, how they are using HashiCorp's tools at scale and so on and so forth. So this is something which I'm not going to cover. So what I'm going to cover is that the real updates of the core HashiCorp's products. So let's go through. So on a high level, these are the updates. So Terraform 1.0, HashiCorp, some updates to the HashiCorp's cloud platform. There is some updates to the Waypoint, some updates to the Packer and Vagrant. So we will go through this one by one. Yeah, I try to cover as much as possible. As I mentioned, there are also some other minor updates of some other products as well, which I'm not going to cover. So this is one of the major ones. So first of all, HashiCorp Terraform 1.0. So a lot of people have been eagerly waiting for this 1.0 version. Like the Terraform has always been kind of into this minor version, like 0. something, and people were like, companies and enterprises were like really looking for where this 1.1 happened. So after a long wait, people found that there was nothing really extra as a feature in 1.0. So this is intentional. The Terraform, the HashiCorp didn't want to have 1.0 release as an added feature set. Instead, they were actually trying to get some kind of a stability around it. So for example, they wanted to have interoperability, which is basically, there are nowadays lots of Terraform, or sorry, HashiCorp tools themselves, and they would like to work because of the compatibilities and other things. So they wanted to fix some versions and then try to support. This is basically for the enterprise level customers, right? Like we don't want to break things. When you want to upgrade, you know what to change, what changes, and so on and so forth. So the next topic is also about upgrades. So they wanted to have a fixed upgrade and also talk about the maintenance for a certain version for a longer period, just like in the enterprise lifecycle, like any other product actually happens, right? So you have a big release, and then you have .x releases, which comes with bug fixes, patches, and so on and so forth. And then if you want to go ahead, continue with that, there is a maintenance period where it's supported and you can continue using it for a longer time, and then go on to the next version with a yeah. So from the upgrade parts to 1.0, so they were saying that the people who are below 0.14, they would recommend that people do a 2-step upgrade. So for example, people who are, let's say, in Terraform 0.12, they would recommend that first you upgrade to 1.14 and then do an upgrade to 1.0. So this is what they recommend. This is because they say that Terraform 0.15 is actually 1.0 beta, and Terraform 0.15.6 is technically 1.0. general availability, so GA. So in the sense, so typically they have released a small minor version, but then kind of renamed that version into 1.0. Then they also think that there will be also future releases like Terraform 1.1, 1.2, and so on and so forth, which has lots of security updates and bug fixes and patches and so on and so forth. So this is the plan. So for the enterprises, it's kind of very good news, so that you can actually now get into a stable version where it's going to be supported for a longer time than the normal ones, and then also have a good interoperability across all the tools. So this was one of the major update from there. Then there was some updates about the HashiCorp cloud platform. So this is the cloud platform as a service provided by the HashiCorp itself. So there has not been so many features, or not all the tool sets of the under the HashiCorp umbrella doesn't work in here. And this is because it's a platform as a service. So you basically have to choose what kind of infrastructure provider you want to use, either AWS, or you have to choose them, and then so they are slowly integrating things. So they had console, which has been released, I think, last year sometime. And then now they have federated clusters from console. So basically trying to get your service mesh federated, in the sense you have multiple clusters in one region, and then there are multiple clusters in another region. You could actually tie them and make them talk to each other, and so on and so forth. So the plan is to release it in July 2020. So this is anyway in work in progress, and it's going to be released soon. So there has been also some updates to the Packer inside the HashiCorp cloud platform, and also as per the HashiCorp, there has been thing that there is AWS Transit Gateway was one of the important or very much awaited features. So this is something which they have released, not much, but something. Then there was some updates about the waypoint. So first of all, I would like to talk what a waypoint is. So waypoint is a way that you could actually define your release phases. So if you were to put it like, you could actually define multiple phases for your pipelines. For example, you could define a build phase, deploy, release, and maybe even testing phase, and so on and so forth. So you can define how this is being done. So just to be sure, this shouldn't be confused with the CI/CD system. So from the waypoints point of view, it actually integrates with your existing CI/CD. So it could be a GitLab CI or GitHub Actions or Circle CI. So you basically integrate the waypoint into that, and then try to actually define your phases in what you want to do. So some of the updates to the waypoints were like they have introduced sync, which has been a problem, that you could now actually tag configurations from the Kubernetes config map and so on and so forth. So you could actually get those values, you don't have to duplicate them, and so on and so forth. And they have introduced health checks, and Waypoint nowadays like natively support GitOps, like, anyway, you could actually commit the code into the version control and then do it in a GitOps way. And then they kind of claim that as mutable deployments is supported, but basically they are using some kind of a templates to achieve this. So Waypoint also supports nowadays server snapshots. So you could basically snapshot one of the server, and then you could actually restore and recover. So there are links at the bottom. You could take a look at the video from there, and then there has been also updates to the Packer. So Packer 2.0 was released. So on a high level, what a Packer is basically some kind of a package manager, put it like a packet manager for a set of components. So you kind of claim it like an unmanageable repository of contents. You could actually package them. We define it in a packet. Okay, so for example, you can define dependencies across different components, and then you could also define configurations and so on and so forth. With Packer 2.0, you have this kind of an init, so you could actually initialize this, and then they have separated the plugins out of it, so you could actually add and use other plugins. They've started to use HCL instead of Json. So from the previous presentation, as you see, the HashiCorp itself is trying to incline more towards moving towards HCL. So they are trying to get rid of like JSON and YAML and then try to use HCL. So Terraform themselves are actually going in that direction. Then the background. This was one of the first ever project of HashiCorp, released, I think, maybe 5 or maybe 10 years ago. I don't remember. So background 2.0 is out. And the plan is this. So they are completely scrapping Ruby out of background and then moving completely to Golang. But this doesn't happen like a big bang. They are slowly doing a transition. The initial plan is to actually support the backward compatibility with background shim, and then slowly strip out all the Ruby and then move everything to Golang. Then the question with the plugins. There has been so many plugins which are implemented, which are created by the community. So they are during this phase, they are planning to port the plugins and of course do an externalization of plugins. So take it out of the core, and then some plugins which are not maintained, deprecate them, and then some of them which are maintained, port them to the Golang. And then now use also HCL here so that they don't have this the previous way of doing .background files. And there's also a plan for the background 3.0, so no Ruby, etc. So this is the explanation how they are going to implement it. So there is a background which is not which is changed but still uses Ruby, but then it basically talks to a background Go through background Go, and then it through a Go plugin it talks to the background shim and connected via gRPC. So this way it's not a big bang. Slowly they are going to take away, remove, everything works as now, but then slowly with the newer versions of 2.x, they are slowly stripping away and making a big changes so that your Ruby plugins are probably not going to work anymore. And from the timeline point of view, so for 2.x, the plan is to port. The main intention is to port from Ruby to Go and get the plugins externalized, and then deprecate the plugins and then move the plugins to Golang. And then from 3.0, it's basically like a fresh start with Golang, with all the existing. The plan is to all the existing community supported plugins working with Golang and continue with background 3.0. So on a high level summary, what HashiCorp is trying to do is that they are trying to push and improve the HashiCorp cloud platform. They want to see that they are seeing that probably lots and lots of users are moving towards the cloud. They wanted to actually have and maintain the configuration in one place. So they are moving in that direction. And also see that kind of they are migrating towards Golang because most of the tools are implemented in Golang and Terraform and almost their tools. So they want all the tools to be also in Golang. And also they are trying to unify like basically all kind of configuration into HashiCorp configuration language. So what Jacob mentioned, the HCL is going to be definitely going to be improved. But then I do not know if they are going to actually support developers to extend HCL to do other things, but definitely this is going to stay for a while. Pretty much that's it from my end. The next HashiConf 2021 is going to happen in October 19 to 2022, but it works. It's on the BDT time zone. It's not in the European region, but yeah, this is the date. Yeah, pretty much that's it from my end. You have any questions? There are links at the slides, so you could actually go and watch the updates. As I mentioned, HashiConf has been quite nice. There has been lots of updates, but then also there has been also lots of talks from the companies who actually use these tools at very high scale and their best practices and all kinds of hurdles and lessons learned when operating it at scale. So there has been that kind of talks as well, which have not covered on this.
All right, let's direct the mic a little bit more. So yeah, it seems that some people dropped out, so there are fewer of us now. There's few faces I don't know. So hello, Thomas is yet. Too bad everyone dropped out. That's the best part. That would be my closing words. We can go straight to that.
It'll be a show.
Yeah. if people don't need a 5-minute break.
I think we can just go.
Yeah, just make them really good. Make everybody regret that they left.
Yeah. All right. So first of all, thanks to all people who gave talks. Thanks for Katie for setting us up with Zoom and other help, and of course all the people who attended. Let's go for the next slide. So yeah, this meetup has been recorded and will be shared, as well as these slides. We have to work out a few technicalities on how to do that, and which is the best way to do that. But we keep you updated in the meetup group. So keep checking that out every now and then. I think it sends notifications when we send a message to that. But then to the exciting part. We already have now this is the release statement of the second HashiCorp user group meetup, and it's scheduled to be on 23rd September. The same time, hopefully, at least partially face-to-face, and we have most of the speakers confirmed for the next meetup. And when I say partially face-to-face, you can go to the next slide there. There's the two confirmed speakers. There's Petri Autero, and he was here for a short while. He come back? No. Anyways, he's a guy who has worked on Terra grants previously, tool I'm very fond of, and I asked him to come. He's going to talk about how Terra grant was conceived, how it was developed. And then we have Robert Strand from Crayon, residing in Norway. I'm probably going to be giving the presentation remotely, and attentively is going to talk about the new Terraform cloud development kit. But there are other possible topics there. Like this is the one he was very excited to talk about. So we maybe want to go that, but we keep you posted. And for the next slide, for the third one, we have a few tentative speakers, but nothing yet. Could be you if you have any super cool stuff to share with us. And anyways, like we try to be open here, and if someone has a cool topic they want to talk about or give a demo presentation, with Robert, I was talking about having a roundtable chat or a tutorials things too. Those are all welcome. And for the next slide, then we are also open for sponsorships. So if you have a company that would be interested in like offering a venue for a face-to-face meetup, some snacks to it, maybe offer the merchandise and so on. We're always open for that. So I can be contacted through email and LinkedIn. Why not? And considering that this is our first meetup and things are slowly taking shape, and we are all open for ideas, feedback, especially offers and so on. So for me, that calls for the end of the formal part. For the of meetup, and next would be the informal part for socializing and so on. But considering that we are on Zoom, it may take some warming up to do. Thomas Autia, I know. Thomas Koivusalo is a new face to me. How are you, Thomas? Silent.
Not better to be silent and just leave, not altogether. So I ask you to speak. Oh, where did he live? Hopefully not.
Oh,
I'm always okay to chat,
that's cool.
but I already did quite a bit of talking, so. But I can talk more.
Sure thing. I actually have, when it comes to future meetup, I have tentative speakers lined up for, like, the idea is that we'll have these once in a quarter. So like this is the Q2 meetup of Helsinki HashiCorp user group. And the next one's going to be in September, and maybe December, the third one this year. It could be maybe earlier because people are often busy in December, but that hasn't been decided yet. But anyways, I've been in talks with a few people about presenting in the Q4, but people are busy, people are going on holidays too. So for Q3, for some people, it was a little bit too early.
Yeah, because there's like HashiConf coming up in October, I guess. That maybe after that might be good for you. Have some showcase meetups, kind of see all new cool stuff
That would be nice. Also, like maybe have some sort of a like hands-on workshops too.
would be good.
Like
Getting started with this tool, or
like I'm very interested in console, but I haven't had time to try that out myself.
getting started with just console is quite nice. Cool.
Also, like this waypoints. What's that new? Like completely new.
It's relatively new. I think in their release
Last October. Last
late 2020.
Yeah. Same.
I'm really curious about Waypoint and like what's a really concrete use case, because it's kind of like the CI/CD landscape is already so rich, and I'm to me, like, the major competitor seems like a makefile almost, that like like you can kind of wrap most useful things in a makefile, but then you don't get any real feedback. It's like command passes or fails. So I would see that's where really Waypoint would shine, if that's like how I would see it. That you would run something and it would deploy something, and it would do more than just run the deploy command, but it could then like give you more info about how that went, and what the end state is. Or
so instead of make deploy, you just write Waypoint deploy, something like that. Maybe
That's the difference.
Yeah. Well, I'm not gonna judge it because I haven't been using it personally, but to me it kind of feels similar to makefile or like GitLab CI file or whatever you're using.
That's also interesting. Like now, Vagrant is moving to use HCL, and like the uniformity of HCL is like.
Yeah, I think they are streamlining everything into HCL and Golang.
Maybe Jacob, you guys were a little bit too early when adopting HCL, so.
well, yeah, I mean, when we started, HCL2 was in its own separate branch in the GitHub repository. So HCL1 was like, if you go to the GitHub repository, it's like, yeah, here's HCL1, and then like if you want to use HCL2, then here you go. And HCL2 is the one that introduced all of the nice goodies. And I think even HCL1 might have used the older parser in the beginning too. Like the original parser was written in Ruby or something. It wasn't like native Go. And then somebody from the community wrote the native Go parser. So yeah, it's been a little bit of a like all projects, just takes a bit of polishing. But I think HCL's main use case is if you want to do something like here's a way for users to provide some input, whether it be config or whatever, and you want to give them that like little extra power that like they should be able to transform a raw string before passing it in, and they should be able to do that in some easy way. They should be able to read a file on the file system, extract this thing using like a regex, and then provide this thing. These like little extra tricks that you would have to do otherwise in some like bash command or something else before sending into JSON or YAML. I think those little things are where HCL are really useful. Other than, you know, if you're just comparing HCL versus JSON or something, then it's more like, what's your favorite syntax?
Yeah, I think one of the things I think is that HashiCorp doesn't want people to, or like they are not really investing on people to adopt extending the HCL itself. They want people to learn HCL because they want all of their tools use it. Probably they are investing it there, but not investing on something that could actually build tools on top of HCL, because that's not their core business, right?
Yeah, it's an interesting, I mean, because HashiCorp generally are quite a community friendly tool. So, or a community friendly company. I mean, that's how all the tools have become such industry standards. And I feel like HCL is so critical, but then maybe it doesn't receive the same level of investment that they have developers working like full time to help with community things. So I guess, yeah, I guess like you said, it's just where the focus is. But I mean, you don't need to extend HCL. Like you don't need to change the code base or anything like that. It's just, I think if there were just more examples available and more documentation around this, then that would already be a massive help.
Yeah, that's true. But pretty much even the HashiCorp internal teams are going to face these problems, right? Like they need to, yeah. So I think definitely this is going to improve.
Unless they have some internal documentation that's better than anything that's out there.
Yeah. I mean, it's always a good, or not a good sign, but it's always a good sign of something not being great. When if you check like issues and things, and there's the one guy who jumps in every time and just does a mic drop on everything. And even Hashimoto, like where he's tried to answer, then I think his name is apparently Mart or something on GitHub. He always comes in and writes these really long explanations about like why this isn't possible or why this would be difficult. And he's the guy who seems to know HCL like in and out. And I'm not sure if anybody else, at least nobody else on like publicly facing seems to. And he's also worked on the CTI, the CTY type system. So like he's really informed. But yeah, it's a bit worrying when there's always the one guy coming in and he seems to be the only one with all the answers. That.
No, it's only four of us. Yes. One thing that saddens me a little bit is that the fading on Ruby, because I like the language.
Yeah.
And it's one of the last great bastions of Ruby is now being overrun by Go.
No, yeah, but if you think about it, I attended the Euroku conference. It's the fully Ruby conference, and they have. From there, it looks really green. Like it's not that okay, everybody's dumping Ruby. I think HashiCorp is probably doing it because they want to streamline things, right? They don't want Ruby developers, Golang developers. You know, in the market, you basically pick Golang and that's it. Most of their tools are like that, and they definitely want improvements to Vagrant because they see it's still probably useful, right? Like you could still people want to use VM virtual machines. So it's not that there are so many better improvements coming there, and as far as I see, it's going to stay and it's not going to die away or something. I'm also have worked on Ruby for more than a decade now, so it's if it goes away, I've lost a lot of time and money on that.
I personally would not.
So
Yeah.
yeah, but personally, I'm really happy because I won a bet with Bakran actually going for Go, because I have quite a few friends in Tokyo and I get to visit there from time to time. Not in the last 2 years, but usually. But the Japan as an engineering society, it's really like diehard for Ruby because of Ruby on Rails. I guess is from a Japanese developer,
Yeah.
and they're like, "No, you use Go. How dare you?" Like,
The Japanese people tend to be very.
and one really great point there. Like, Vagrant is in Ruby, so of course it's good though. As you can see, it can be used.
Oh,
And
then
then
it's
next time I come back and say, how's the Vagrant going on, by the way? Still using Ruby?
Then they are like telling probably I don't know, is it Twitter or something? Yeah, it's running on Rails.
Maybe.
GitLab and something.
GitLab is running on Rails, and Spotify is running heavily on Rails.
Yeah.
Not on Spotify, but Shopify.
Shopify, yeah.
And then Spotify maybe as well. Wouldn't be surprised.
Yeah.
I think it was some. I don't know.
But a lot of companies, wasn't Facebook running on Rails before? Like a lot of companies actually moved out of Rails because they had huge performance.
I think they were a PHP house to begin with.
Oh, yeah.
Yeah, but they might have gone to Rails after that. So
I don't know. Yeah, one of the big.
From what I understand of Facebook architecture, it's so like it's a micro architecture in a real sense. So like they can just phase out the different components and rewrite them.
Yes.
Anyways, we're still recording.
Oh, yeah.
But like, don't stop it now. Like, if someone's watching this in the future, thanks for watching this part. So, and thanks for Jacob for staying with us this long. So, it was a good first meetup. Next one will be in Meta.
Yeah, nice work, Lauri and Anup and Antti. Nice to.
Yeah.
Nice to.
Nice to kind of meet you virtually.
Yeah, exactly. Sorry, I couldn't be in the office next time.
You're the safe one of us. So if we get infected, then you'll be left to carry on.
Well, that wasn't the reason, but yeah.
That wasn't the reason anyway.
Yeah. So
What happens if you end the recording? Does that kick me out the meeting?
No.
No, okay, we'll just end the recording then if you haven't already, I guess.
Thanks.
Thank you.